In this video, I want to show you a computer simulation to illustrate some of the aspects of wave interference that we've been talking about. And what I'm going to do is access a website called Phet Simulations, and that's spelled Phet, and we'll go to this simulation and we'll have a look at some wave interference. Right, here we are on the internet, and up here you can see I have Googled, so to speak, Phet Simulations, and what I'm going to do is go to Physics and go to Sound and Waves, and the simulation that I'm going to get is this one here, wave interference. Okay, that one there. Now this is something that you can download. I've already downloaded that, so I'm going to click here to start it. So this is the first screen that you see, and what we've got here is a source of waves. So that's a drop of water hitting the surface of water, and down here you can see how it's possible to adjust the frequency of the drops. So I can pull this up here, and those drops as they hit the water create waves, and then they spread out. And here we can change the view that we've got. So if I click that, you can see there, these are the waves that are generated. So we're kind of looking at these waves from the side. Now we can adjust the amplitude of the waves as well as the frequency. So if I click here and drag this up, you can see I'm making the waves bigger. We're increasing the amplitude. Now to have a look at the interference that I'm talking about, what we need to do is get another one of these, and to do that we go over here to where it says 2 drops. So I'm going to click there where it says 2 drops, and now you can see we've got those 2 drops coming from those 2 different taps. As they come out, we get an interesting pattern, and these patterns are, first of all, crests that are travelling out here. They're the blue parts, if you like, and then the black, which is the troughs. Now the interesting pattern is these lines here, those lines, as if nothing is happening, okay, along there. Now the question is, what is causing those lines? Now the answer to that is wave interference. What's happening is that we are getting destructive interference all along those lines. So what's happening is the crests from this source here, for example, are meeting up with the troughs from this source. So everywhere along these lines we've got crests meeting troughs, or if you like, we've got troughs meeting crests. Now here in the middle, it is in fact areas where we've got bigger waves, in other words, greater amplitude. And that greater amplitude is, of course, troughs meeting troughs and crests meeting crests, and the result of that, of course, is constructive interference. The amplitude of those parts of the waves are built up. Now we can see this with water waves, and I'll just change this now so we can have a look at light waves. So I'm going up here, I'll click light, and at this stage I've only got the one source, so I'll go back over here and click here where it says 2 lights. So I've got our two lights there, and I'm going to increase the amplitude. Now the other thing that when we have a look at lights here is where it says here show screen. So I'm going to click that, and I'm also going to increase the frequency. So we're going to look at a different area of the spectrum. Oh, sorry, that's the amplitude. So change that up and bring down here, and we'll change the frequency. In fact, we're increasing the frequency now. Now if we have a look at the screen, so this would be for light, you can see here these same lines. Now what those lines of course represent is destructive interference. What we have is the troughs of one source meeting up with the crests from another source, or if you like, crests meeting troughs, troughs meeting crests, whichever way we like to say that. Here, of course, you can see a bright area. That is in the center. When I say it's in the center, it's between these two. So it's where, again, the crests meet crests and troughs meet troughs. So we have here what we call a bright area, or a bright band, a central bright band. Here we've got what's called the first dark band, and then again we've got a bright band where we've got constructive interference occurring there again. I'll just bump up the frequency so that we're looking at a violet light. We'll see what sort of, it's rather hard to see there, but anyway, now we can see the bright bands. And what happens in this particular case now, which isn't important, but we've now got more of them. So again, what we've got here is constructive interference, destructive interference. So this can occur when we've got two sources like this. Now this process of creating sources indicates, first of all, that light is a wave. It's very much a piece of evidence that light is a wave. Perhaps we've come across the story before that light was thought of initially as a particle, because there are reasons, good reasons, to think of light as being a particle. But this particular experiment, if we do it with light, certainly shows that light is a wave. So the light waves behave very, very similar to the water waves and indicate both constructive and destructive interference. We do also have sound. I can just move up here, the pointer up here, click sound, and again create two sources. So over here, two speakers, and I'll bump up the frequency. Show the graph, not that that's... And again there you can see with sound, I guess all they've done on the computer is change the colour, but anyway, again we've got here these lines, and these occur with sound. So those lines there are instances of destructive interference, where troughs meet crests, or crests meet troughs. Here, troughs and meet troughs, and crests meet up with crests and give us constructive interference. So again, this illustrates that sound is a form of a wave. We can't actually see sound, but when this does happen with sound, then that does indicate that sound is a wave.